Dear students, today we'll start organic chemistry. So to begin with, we'll start with nomenclature of organic compounds according to IUPAC nomenclature. I have these notes for nomenclature of organic compounds. So we have already learned in class 11 also. Just for revision, I'm taking these notes. So this is the main format, right? So first we have to write prefix, then word root, then primary suffix, then secondary suffix. Okay, in this format we'll write the name of the organic compounds. Now what is word root? Word root means it denotes the number of carbon atoms present in the chain, right? So if number of carbon atom is 1 in the chain, then we call it meth. We'll write it meth. 2 means eth, 3 prop, 4 but, 5 pen, 6 hept, 7 hept, 8 oct, 9 non, 10 dec and undec and so on. Okay. Similarly, now next is primary suffix. So primary suffix. So this indicates the nature of linkage, right? So if all the bonds between the carbon are single bond, then we write ANE. If remember all the bonds. So if there are certain double bonds in addition to single bond, okay, or few double bonds may be there, then we write ENE. Similarly, in case of triple bond, okay, all the bonds cannot be triple bond. Remember, there may be 2 or 3 or 1 triple bond or more, okay, then it is called YNE, right? So that is very important. Now we have to note that if the parent chain contains 2 or more double or triple bond, then the numerical prefix such as di for 2, tri for 3, tetra for 4, etc. are used. Okay, and similarly extra a is added to the word root if the primary suffix to be added begins with the consonant. So yeah, consonant means other than vowel, and y is also, yeah. So if in addition to a, e and y, if other alphabets are there, for example di, ene, right, d, so d is not a vowel, so it's a consonant. So if di is there, then you have to add here e, right? So you have to add the after word root, you have to add e. Then secondary suffix, it indicates the functional group, right? So if somewhere in the structure OH is there, that means alcohol is the functional group. Then we have to write the secondary suffix as OL. So here in this place we have to write OL. Similarly, if aldehyde is group, then aldehyde group is there, then we have to write AL. Ketone is there, then we have to write ONE. Carboxylic acid, OIC acid. Ester is alkyl OH, okay, let's say ethyl ethanoate, something like that. This acid chloride, OL chloride, acid amide only, nitrile only, amine only. Now coming to the prefix means branches, right? So basically the non-functional group. So if CS3 there, then it's methyl, then CS2, CS3, or it can be written as a C2H5 is also sometimes written, is ethyl. Similarly CS2, CS3, or C3H5, then it is a H7, then is a propyl, fluorocoil, chlorobromoiodoinoate, nitro, and these are NH2 is amino. Now remember, this is not a functional group. Okay, if there are 2 functional group, then other becomes your principal functional group, then this becomes your substituent. Okay, if there is a 2 or more functional group, then this case arise. Then OCH3 is methoxy, then similarly ethoxy, OH is called hydroxy. Okay, if it is a functional group, then we write OL. If it is a branch, then we write hydroxy. Similarly double bond O is present in a ketone and aldehyde. Okay, but if that is not a functional group, we call it a principal functional group, not a principal functional group, then we write a oxo. One more important thing while adding the secondary suffix is that the terminal e of the primary suffix, okay, primary suffix has a ene, so each one has e, right? So this e is dropped if the primary suffix secondary suffix begins with a vowel and y. However, the terminal e is retained if this complete secondary suffix begins with a consonant. Remember, the complete secondary suffix means die, try, that d is also included, so we have to look for that d. Similarly, for the prefix, if it has a more than one, then we'll just write the die, try, tetra, okay, according to their numbers, okay, and we have to also mention their position while numbering in the parent chain. Now, the rules for IUPAC rules for the nomenclature of saturated hydrocarbons, right? Saturated means it has only single bond. Now, longest chain rule. So you have to find the longest carbon chain, okay. If there is a two longest carbon chain which has the same number, then you have to choose that longest carbon chain as a parent chain which has maximum number of branch. Number 2 says position of the substance, so you have to number it, hey, 1 2 3 4. So there are two ends, right, in a molecule. So either from this side or you have to this side, you have to number it, but you have to see from where we are getting the prefix earlier or the branch first. So next is lowest set of lock-in. So it says the same thing. So you have to, if branch is here, so you have to number from this side, because from here you are getting the branch earlier. Similarly, the next is lowest sum rule. So it says that when there is a tie, like if I'm going from this side and in a two position there is one branch, again I'm going from this position, then there is a two position, there is another branch, right, and there are other branches also here. So that time you have to say for the lowest sum rule. So when there is a tie, then you have to go for the lowest sum rule. We'll deal with this later on. Presence of more than one substituent, then you have to write di, tri, tetra, okay, according to that one. The naming of different substituents, so while naming the different substituents, you have to write that according to the alphabetical order. Then naming the substituents at equivalent positions. The name, you have to look for the alphabetical order, okay. The first alphabet comes from which side, you have to name from that side, you have to number from that side, basically. The naming of complex substituents. So the main thing is that the carbon which is attached to the parent chain in the complex, then that carbon you have to take the one, then you have to find the longest chain from there. Then cyclic hydrocarbon, you have to write the prefix cyclo, okay. Then if you have a more than one functional group, then you have to write a first preference you have to give for the functional group, okay, then double or triple, okay. It should not be greater, but if there is a tie between double and triple, then only the double one goes, okay. Preference will go to the double bond. If there is no tie, then either double or triple, whichever. Then last preference goes for to the side chains. Then preference of the I've already told you the principal functional group, right. While choosing the principal functional group, the preference will be given to the carboxylic acid, then sulfuric acid, then ester, acid chloride, amides, nitriles, aldehydes, ketones, alcohols, amines, and at last ester, okay. So if there is a two functional group, right, carboxylic acid and suppose alcohol, a molecule has a two group, then you have to take this as a principal functional group, and the alcohol you have to take as a branch. Then we know it's a bond line notations, okay, we have already done in class 11. And there are some skeleton structure, you should know these things, okay. A few more diagrams are there, you can refer it. Now coming back to nomenclature, okay. So if this is the molecule, right, so you have to find the longest carbon chain. So first step is you have to find the longest carbon chain. So 1 2 3 4 or 1 2 3 4 1 2 3 4 1 2 3 4, right. So 4 number of carbon in this side also, if I go down also. Now which side I have to go? Okay, now the rule says that now since this is a single bond, so it can rotate. Okay, so this can go up, this can go down. Since tetrahedral structure is something like this, so it can be rotated, right? So we can say this CH3 and this CH3 are at equivalent position. So you can take any of the side, there is no issue. So now I have to number from 1 to 3. So I'm getting 3 branch. So 1, 2 branch. So you have to do the numbering from this side. Lowest set of lock-in. So it says you have to do from the numbering from that side, from where you get the substituent at earliest, right? So this is the numbering. Now you have to name it. So first, okay, I have written this one. So this is the main format, right? Primary suffix, word root, prefix, word root, primary suffix and secondary suffix. So prefix means you have to look for the branch. So this is our parent chain. I'm putting in the box, right? So yeah, so prefix. First you have to look for the word root. So how many? 1, 2, 3, 4, right? 1, 2, 3, 4. We have done the numbering. So prefix is this one, CH3. So CH3 as a branch is known as methyl. So you have to write it is a 2-methyl. Then go for the word root. Word root means 4 is but, and primary suffix means you have to look for the carbon-carbon bond. So this carbon, single bond, carbon-carbon, single bond, carbon-carbon, single bond. So A and E, right? And look for secondary suffix. Any functional group? No. So the name of this molecule is 2-methylbutane. Now I have taken another molecule, CH3, CCH3. Here is CH3, CH3. Now you have to find the longest carbon chain. So 1, 2, 3, 1, 2, 3, 1, 2, 3, right? So all single bonds, I said it can be rotated, so there is no issue. So this is your parent chain. First you you have to make the box. Okay, initially, later on you no need to make this box. So you have to number from either 1, 2, 3, 1, 2, 3. Now which side? Because these two are at equivalent position, so you can do from either side. Remember, either side, no issue. 2, 3. 1, 2, 3. So it's a, now you can write as a, there are two branches at 2 position, carbon number 2 position. This numbering is for carbon, remember. So 2 position. So prefix. So first we have to write the prefix. Prefix means branch. So there are 2 branch at 2 positions. So you have to write 2, 2 dimethyl, methyl. 1, 2, 3 means prop A and E. And remember, there should not be any space between these names. Okay, it should be continuously. Remember also, here also there should not be any gap. Okay, you have to write without any gap, and just after the number there is one hyphen, and between 2 numbers you have to put comma. That's the standard format. Fine. So another example, I have taken this one. So you have to find the longest carbon chain. So 1, 2, 3, 4. 1, 2, 3, 4. You can choose any. Okay, there's no. So 1, 2, 3, 4, 1, 2. So the 1, 2, 3, 4. Okay, if I take this also, okay, we'll have 2 branch. If I take this straight also, we'll have 2 branch. Okay, if I take these 4, again 2 branch. So all are equal, so I will take straight only. Fine. Now you have to do the numbering. 1, 2 branch, 1, 2 branch. So it's also equivalent. So you can do from either side. So I'm taking from this side. 1, 2, 3, 4. Fine. So its name is, now you have to look for the prefix, means branch. So branch has 2 position, branch has 3 position, and both are methyl. So you have to write 2, 3 dimethylbutane. Now you can look at this example. See, you have to find the longest carbon chain. Always use a two pen, okay, either a pencil and pen or two colored pen, different colored pen. So see, you have to find the longest carbon chain. So 1 2, these two are equivalent, so you can choose for either 1 2 3 4 5, 1 2 3 4 5 6. So I'm getting the 6 here. So this is your parent chain, right? 1 2 3 4 5 6, because 6 there's, okay. So you have to number it. Now a number can be drawn from either end, right? Either this end or this end. So 1 2, you are getting branch. 1 2 3, you are getting 3 branch. So that means the numbering has to from the back side. So numbering I'll do 1 2 3 4 5 6. Always remember, you have to write the numbering here, okay? Don't write exactly below also. So 6. So see the soft chains. So soft chains are 2 position methyl and 4 position methyl. So its name is 2 comma 4, 1 2 3 4, right? So hyphen, then comes dimethyl. Methyl spelling is methyl. Don't write methyl, okay? Methyl. Then how many carbon? 6 carbon. Then what root is 6 is hex. Hex, then carbon single bond, so it is a hexane. I'm taking another example, this one. So here is Cl chloro, here is bromo, right? So this is obviously your parent chain. You have to number it now. 1 2 branch, 1 2 branch, right? So in this case, the rule says that you have to go for that, to go from that end, okay, from where you get the soft chain which has whose names comes first, right? This is bromo, B, okay, and chloro, C. So alphabet which comes earlier, B, right? So that means you have to number from this side. 1 2 3 4. So the name becomes 2 bromo, then hyphen, then again 3. Okay, so 3 position of chloro. So while writing the 3, you have to remember hyphen, okay. Then chloro, CHLORO, chloro. Then 4 carbon means BUT, but. Then carbon all single bond, so ANE, butane. Look at this example. So you have to find the longest carbon chain. So obviously this is your longest carbon chain. So look at the substituent. From this side 1 2, you are getting the substituent here. From here 1 2, you are getting the substituent. So both sides, from at 2 position you are getting the substituent. Now from which side you have to number? So for that you have to look for the lowest sum rule. So in this case you have to apply lowest sum rule. So if I do the numbering from this side, okay, so it's a 1, it's a rough numbering, okay, 2 3 4 5 6. Fine. So you have to calculate the lowest sum rules. So it says that so it's a 2, you have to add the position of the substance. So 2 and you have 4 more duita, just 2 plus 4 plus 4 plus 5. So 2 4 4 and 5, right? So this gives you how much? 15. Now doing the numbering from this side, okay, like 1 2 3 4 5 6. Now you have to again calculate the lowest sum rule. So here is 2 plus 3 plus 3 plus how much? 5. So this gives 13. Now according to the lowest sum rule, it says like 13 is the lowest, right? So that means the numbering goes from this side according to the lowest sum rule. So the name becomes, so 2 comma 3 comma 3 comma 5. Okay, so total 1 2 3 4. So it's a tetra. Okay, not but, it's a tetra. T-E-T-R-A. It's a prefix. Okay, so tetramethyl. So position is 2, 3, 3, 5 hyphen tetramethyl. Then how many number of carbons? 6. So it's a HEX hex. Then all carbons are single bond, ANE, hexane. So tetramethyl hexane. 2, 3, 3, 5 tetramethyl hexane.